Okay, go.
Let me give you a little bit of a run-through on this machine. This machine has a hydraulic cylinder down here, about so big and around. The rest of the machine here pumps oil under pressure and feeds it into a chamber underneath this hydraulic cylinder, so it forces it up. As this cylinder comes up, this table moves up. These bars also move up. So this thing here is fixed with its screw jacks into the surface here. I can raise those up and down with these two controls here. Okay. Now, if you put a specimen in here, between here and here, when you raise this, you'll stretch this, and we can apply up to 60,000 pounds of force. If we put an object between the table and here and raise it, I can compress it. So we can put compression forces on objects down here, we can put tension forces on objects here, and since we can raise and lower the table, we have to have some way to grip the object. So let me show you how we do that.
Sorry.
We have these wedges. And these wedges fit inside here. So these turn together, and as they come up, they're inclined on the inside here in the middle. As it squeezes up, it pulls together. So this handle has got threads on the side to help us tighten it. So as we pull down on this, it pulls this in, and it locks it more tightly. This kind of an arrangement allows us to grip something tightly enough to apply up to like 60,000 pounds of force to it. Way beyond anything we're talking about with vice grips. But you have to have something like this to make a secure connection, otherwise it will just slide and pull out. So this is the way you connect things in here. Now, we have other types of things. Some of our things are threaded. So a lot of our tension things, we make samples. Like this. This would be a test sample that we would thread in to some pieces like this, and these bolt into here, and then we can put a sample across like this, put another one like this up here, and then we can pull these pieces here, and with this device on it, we can measure the change in length of this as we measure the force. So this gives you, not only allows you to calculate the force in the member, but also it gives you how much strain you get in the member, how far you stretch it. So we can get the properties of a piece of material, and we can draw a graph of it. You've seen these graphs in the book where they go stress and strain, the force on the vertical and the change in length on the horizontal, and as you pull it, you get a straight line for a while. That's Hooke's law. And then it starts to curve and stretch like a piece of taffy. Someplace along here it'll break. Some materials will stretch a lot farther than others. Some stretch very little before they break. Cast iron, notorious. It breaks very quickly. It doesn't stretch much. But we can test all those kinds of things. What we're going to do here is we're going to use this, and we're going to hook our vice grips onto this end down here, lock them, and then we're going to apply the force up to pull the vice grips off. And we're going to see how much force that takes. First thing I have to do is turn this on, and you have to raise the table up. It's resting on the supports. You have to raise it up to its operating position. And there's a little bar here on the back that comes out as a safety trip, and there's a mark that we put on that just to get the thing up. This is the unload button here. When I open this one, it lets the oil out and the thing settles back down. As I open this one, the thing starts coming up. The farther I open it, the faster it comes up. Now once we get our sample in it, we'll use it running fairly slowly to increase the force. So first thing I have to do is get it up. It's racing upward right now, gentlemen. Racing.
Is it going up?
That's probably good. We're talking about 10,000ths of an inch kinds of things here, so.
is the Pascal's principle?
Yes, exactly. All right. Now, this digital we have right here, go ahead and push down on this table. Just lean on it and push down. You'll notice that as you do, we get that reading right here. So if you actually climbed up and stood on it, we could weigh you right from there. So this thing is tied to this, so we can measure the force. So what we're going to do is we're going to hook our vice grips on, and as we lift it up, that force is going to go up. Now the first thing that'll happen is we're going to start stretching things, and we'll actually stretch the aluminum a little bit. But then the force is going to go up to a point. When it gets high enough, this is going to start sliding. You won't actually be able to see it slide because we're going to be going slow enough. But
wait, we won't be able to?
Well, I suppose you can. Let's make a.
Now the aluminum that we're this is the aluminum of the thing that we're okay.
So now
the key. This is the aluminum key.
So now I'll turn this on, and we'll start. Now you notice it's still vibrating, so I haven't even got it up far enough to catch it to stop it from wiggling back and forth. Well, there is a little of that.
Back up, you don't want to get hurt.
Yeah, we don't want your head to be in there, Justin.
If we had, if we made it a little better, if we had a slot.
You know I'm recording.
Yeah, then it would be a little more accurate. I was absolutely right.
So, okay, so let me just get a good shot here of what we're looking at. Kind of difficult because of the... But we're like nowhere near measuring anything, right?
Right, I'm just trying to curious why I'm getting
No. I think aluminum would probably be relatively, it would probably stretch a lot. Yeah. Aluminum's very tough.
Oh, I see what we're doing. Oh, it's going down. Let's see if I can get a better shot of this. It's not for me, it's for all the kids that can't make it.
Who cares about that?
I do.
You hear me, kids? No one cares about you. Well, Martha does, but whatever.
So, this thing is coming down, Professor, and testing...
We're not actually having an issue.
Okay, gentlemen, the first thing we need to do when we get our engineering degree is buy a brand new machine for this school.
Yeah. Why?
Yeah, it's the same thing. I think Schiller would prefer, like, probably a Porsche instead or something.